Okay, Chapter 1, the composition notes are on page 12 and 13. Composition appears in two forms. It can be written either of these ways. This is read f of g of x, and this can also be read f of g of x, but to separate it so you know which form you're writing, people will read this f circle g of x. F circle g of x. We will use f of g of x notation, but you will note that this notation is still popular. Kind of looks like the word fog, only this little circle is supposed to be smaller. Okay. So first we're going to, how would we evaluate? You would evaluate first whatever value's in for x at the value of g, so g appears first. You would get that answer. And now that you know the answer of g of x, whatever value that is, you would evaluate this in your f function. Now, I want you to realize that f of g of x and g of f of x are not commutative except for when you find inverses. So be careful, don't assume you can do one way. So given this function, what if I want to find f of g of 2? Well, the first thing I need to do is find g of 2. So I came over and found g of 2, which was 10. So I replaced the g of 2 with the 10. And now I find f of 10, which is 3 times 10 minus 1, and I get 29. But I'm not going to get the same answer when I do it the other way, because these are not inverses. So I want g of f of 2. So the first thing I need to know is f of 2. Well, f is 3x minus 1. So I did 3 times 2 minus 1, and I have 5. So I replace f of 2 with the 5. And g of 5, well, g said multiply by 5. So I get 5 times 5 is 25. So notice that g of f of 2 is 25, but f of g of 2 is 29. Now for my second example, here's another one, and I do these in linear functions just to get the idea across. You all should have this stuff down at this point. I want f of g of 3, so I have to figure out what's g of 3. Well, g of 3 said to put it in for x. 8 minus 3 is 5, so g of 3 is 5. F of 5 is 2 times 5 times 3, and I get 13. Let's try it the other way. I need to know f of 3, but f of 3 I need to insert here. So f of 3 is 2 times 3 plus 3 is 9. So my f of 3 is 9, and now I want g of 9. Well, g tells me to do 8 minus whatever the number is, and I get negative 1. So g of f of 3 is negative 1, but f of g of 3 is 13. Now this process gets very, very old, and so what we want to do is rewrite the composite function f of g of x into a rule for a single function h of x. So when I come down here and I'm looking for a new function for f of g of x, and I want to come in and find it, I could have called it h of x down here or y, but I just showed you the two different orders. What if I want to know the function f of g of x? Well, the first thing you need to know is these x's are not necessarily the x coordinate. They're just a placeholder. And so there's going to be some stuff in here. And whatever this stuff is, I want to do the rule to it. So you have two ways of thinking of this. You can write it in words and say 2 times my stuff plus 3. Or you see this is a parenthesis and you want to replace this parenthesis x over there. So whatever's in the parenthesis goes in there. The same for g. What does this really say? I got some junk in here, and so 8 minus my junk. Or, I wasn't supposed to have that. I have a parenthesis the empty parenthesis, and over there, wherever x is, will be a parenthesis. You can think of it however you want. But f of g of x would be whatever g of x is. Well, what's g of x? It's 8 minus x. So I inserted it. Now that I've got that, I want to apply my F rule. What does it say? 2 times stuff plus 3. Now, whenever your stuff is more than one term, you must, she repeats, must have a parenthesis. And that's why some people think of a combination. I always think of when I do composites, I never use the times dot. I always use a parenthesis. So now my stuff is 8 minus x. So 2 times 8 minus x, add 3. And I went ahead and I just did my operations, and so my function, if I wanted to name it h, would be h of x equals negative 2x plus 19. Its domain is the reals. Now notice g of f of x is going to be different because these are not inverses. So g of f of x, what would its rule be as a single function? Well, first I need to find f of x. Well, f of x is 2x plus 3. So I insert 2x plus 3. Then I apply g. It says 8 minus junk. Is there more than one term? Yes, there is. So I must have a parenthesis for my junk because I need to subtract both 2x and 3. Or I can just have thought the parenthesis process. I distributed and my domain was still the reals. I'm not doing anything tricky with domain. So notice this function is negative 2x plus 19, and this one is negative 2x plus 5. Let's do just one more. I'm going to get fancy and put in a square. So f of x is a parabola, g of x is an oblique line. So what does the F rule say? It says 2 times your stuff squared, and then add on 3. G is still 5 minus junk. Why am I big on this 5 minus junk? I do this one twice because you turkeys forget to put a parenthesis around it and screw up your answers. Now, I could use the parenthesis notation. Wherever I see parenthesis x here, I just replace that x with the parenthesis. So I need f of g of x. Well, what's g of x? G of x is 5 minus x. So now I want f. What does f say to do? Square your stuff, multiply by 2, add 3. Square your stuff, multiply by 2, add 3. Folks, that's called order of operation, a little 6th grade math there. So when I square the first, square the last, first times last times 2. I distributed, then I added my 3. So my final function, or instead of having to do this process, if I know what x is, I can just substitute it into this formula. And so if I want to rename f of g of x as h of x, I would say h of x is equal to 2x squared minus 20x plus 53. Now going the other way, g of f of x. Well, what is f of x? F of x is 2x squared plus 3. So I've inserted it. What does g say? Do 5 minus all of your stuff, not just the first term. It's more than one term. You need a parenthesis. And I end up with negative 2x squared plus 2. And yes, the domain of all of these is all reals. I didn't give you any radicals that have had even indices, and I didn't give you any denominators.